that I will slow down. My speed of speech will slow down so that people can get what I am telling you. Okay. So now you see here we are going to learn about semiconductor. So in previous class, in previous unit actually, we have learned about different type of materials like your conductor, insulators, and your we can say that your semiconductors. Okay. So in conducting conductor means what? Those we know that by from the name itself we know that conductor are those materials which are going to conduct the electricity through them, or which is allow the current pass through them, that is called as a conductor. Insulator are those materials which are not letting the current pass through them, that is your insulator. Similarly, semiconductor is a material which will lie between this conductor and insulator. So to identify which is whether it is a conductor or an insulator or a semiconductor, we are having three criteria. Okay, any one of the criteria we can use it, and you can define what is a conductor, what is an insulator, and what is a semiconductor. The first and very foremost thing which we generally doing is the property. Okay, property. A property means what? A material is able to conduct the electricity, then we can say that there the material is having a good conductivity. Okay, that is what is the property of the material. We are not developing that thing in the material, it is a inbuilt thing. Whenever the material comes up, or whenever we see the material from the starting onwards, we saw that it is having that capacity to conduct the electricity or to conduct the energy, either it is the heat energy or it is a electrical energy. So it is called as a conductivity, property of the material, that we cannot change it, that we only change the amount of that property according to the working situation or due to the external factors, but we cannot control it, or we cannot change it actually. Okay. The next thing is your concentration of free electrons. Okay, this concentration of free electrons I am going to tell you in a bit, and this energy band diagram. Okay, so those who have attended for unit 3 classes for me, they must have know I have told you that basing upon the energy band and the gap in between those two, we are identifying that whether it is an insulator or a conductor or a semiconductor. Okay, I have shown you something diagram like this, one graph I must have shown you. I must have shown you a graph like this. Here I have told you this is a conducting band, and this is the energy gap I told you. Okay, this is I told valence band, this is I told conduction band. If this band gap is less, that means if this conduction band and valence band overlap each other, we call it a metal. If this conduction band and valence band is having very less gap in between them, we call it as a semiconductor. If that gap is very high, then we call it as a insulator. So this thing I already told you in conducting material part, right? But I have not explained you how did we got this energy band. Okay, what is this energy band? Where we got this one? Why we call this as energy band? How we are defining those two bands? What is this energy gap? And what should be the amount of that energy gap that will going to define a semiconductor, that is going to differentiate a semiconductor from insulator. Okay, so those things we are going to learn in this chapter now today actually. Okay, today I will try to finish off this part so that tomorrow we will be going to cover the other part of the semiconductor, like the types and the application and the temperature dependency. Okay, so before going to that, we should learn what we are going. You should know what you are going to learn in this particular chapter, which I didn't told you. Okay, so this is the part, this is the thing you are going to learn in your semiconductor, which I should have told you earlier, but I didn't told you. So we are going to know what is a semiconductor. Then we will know what are the type of different semiconductor and its temperature dependency. Then we will see compound semiconductor, amorphous and organic semiconductor. These are the, this is the content you are going to learn. So this is what is the introduction part. As I told you, the electronic materials are classified based on three categories, like a property of the material, like conductivity and resistivity or resistivity. See, a material is having good conductivity means it is having the low resistivity. Okay, like copper. Copper is a good conducting material, right? But it is having low resistivity towards the conduction of electricity. That is why conduction is good over there. But if I will consider your steel as compared to copper, then steel is also a conducting material, but its resistivity is more than that of your copper. That is why even if we are seeing different conducting materials also, like examples here given, silver, gold, copper, steel, seawater, or we can say also this brine solution also, that is a type of electrolyte. These liquid conductors are called as electrolytes. Okay, so these are having different conducting capacity. This conducting capacity we represent with a conducting constant, conductivity K we are representing. That conductivity K is different for different materials. For silver it is the highest value. Okay, if we compare these examples of solid here, silver, gold, copper and steel, then steel is having the lowest conductivity. That's why silver is having the lowest resistivity and steel is having highest resistivity. So I can say, whereas in which material conductivity is high, their resistivity will be low. Where conductivity is low, there the resistivity is going to be high value. Okay, that is what is the property of the material. Second comes as concentration of free electron. Okay, so when we were telling we were discussing about different type of materials, there I told you about this particular material that is called as your metal, right? Why we different or metallic bonds, right? So when I told you about metallic bond, and then in that one I told you about something like your free electron. Okay, something I told you about free electron. Okay, so free electron means what? These are the electrons which are going to be, which are not present in the atomic structure. It is out of the atomic structure, but it is a part of the atom. Okay, like you will, like, so we can say that those children are staying in the hostel. Okay, so they are the part of the family, but they are staying free, right? They are free electrons. They are not bound to the rules of the house. Like if I consider me, let us consider I am staying in a hostel. So I am bound to, I not in hostel, let consider, you can say I am staying in outside in a separate room, and I am staying with there. So I can do whatever I want, right? There is no rule for me. I am not supposed to get up at early in the morning. I am not supposed to eat at the proper timings if I don't want to. But if I stay at home with my family, my parents, they are setting some rules for us, because for our health, right? So they are saying that you have to wake up at 7 o'clock, you have to eat in the time, like that. So you, when you are staying in outside your family separately, you are a part of the family, but you are not bound to the rules of the family. Similarly here what happens, free electrons are like that. Okay, so free electrons are what they are doing. These are separated from the atomic structure, present freely. When we need to let the current pass through it, these electrons are going to move in there to conduct the electricity. Otherwise, they will be present free and roaming randomly. They will be moving randomly. Okay, but they are the part of, but they are not bound to the atomic force. Okay, so we are having this nucleus now. This nucleus is attracting its electron towards it. right? It is attracting the electrons towards it. Now this electron is out of the atomic structure. It is a part of the atom, but it is outside the structure. This is not bound to this proton present at the center, or the nucleus present at the center. That is what is a free electron. So in a metallic bond we see that there is a free electron cloud is there, and randomly these positive ions are there, which are creating this, which are making sure that the electrons are present in a particular cloud format. Okay, that is what is a free electron. Okay, now the question comes, where does this free electrons are coming from? Okay, so okay, these are this, where does this free electron coming from? I am going to tell you a little bit later. As of now, remember that we are having this number of free electrons. This is like your, as I told you, we are having two bands, right? One is your conduction band and another is your valence band. In valence band, the atoms are present. Okay, we know that one, because this is the part of this valence band will be associated with the atom, so electrons will be present, but these are not free electrons. But free electrons will be present in the conduction band. Now if there is very less number of free electrons are there, means it is having less conductivity. Okay, if there is no free electron is present, then it will be a insulator. So no free electron means it is a insulator. Similarly, if more free electron are present, means more the conductivity of the material is there. Okay, so if number of electron present in conduction band, this is what is saying that, this is what this condition is saying, that the concentration of free electron means the number of electrons present in the conduction band, that is the concentration of free electron. If this concentration of free electron is high, then it is a very good conductor of electricity. If the concentration of the free electron is low, then it is a conductor, but with a low conductivity value. Similarly, if there is no free electron is present, then it will be insulator. Okay. Similarly comes your energy band. So basing upon this concentration of free electrons, or we can say that the presence of free electron is going to decide the energy band theory. Okay, this energy band, if as I told you, if I plot a graph, if I tell you that this is a conduction band and this is a valence band. Okay, then we are having three cases over here, like your these are the three cases I can say. Okay, you can see this is a conduction band, this is the valence band, this is also conduction band and valence band. Now you see this valence band and conduction band that is overlap with each other. That means there is no need of energy, external source of energy is required to make the electron present in the conduction band, because this conduction band itself is overlapping with the valence band. That means free electron is present. Here very less amount of energy gap will be there. So if we give some little bit amount of supply of energy, this electrons present in valence band will jump to the conduction band and they will be start carrying the electricity. But if this gap is very high, even though the supply of energy is more, then it will require means some high amount of energy it will be requiring to jump this valence band electron to the conduction band, which is quite difficult, actually not impossible, difficult. So with much difficulty we can say that the electrons from valence band can jump to the conduction band. So this will be a insulator. Because of that, this will be a insulator, this will be a semiconductor, and this is a conductor. Okay, this is what is the energy band theory, and basing upon this we have divided these three types of materials. So as I told you, conductors are those which are able to let the current pass through it because of the presence of the free electron. Similarly, if a material which is having insulator is the material, then it is not having any free electron in the conduction band. That's why it is not a good conductor of electricity and it is not going to let the current pass through it. So it is a insulator. But when we consider a semiconductor, we see that this particular material is going to show both the properties. That means a semiconductor at low temperature will act as a insulator. Semiconductor will act as a insulator at low temperature, but at the same time at high temperature, relatively high temperature, we can say that these are acting as a conductor. That's why they are called as a semiconductor. Now, so here we can by changing the amount of temperature, external working temperature what we are supplying, we can tune the capacity of conducting capacity. Okay, we can tune their conducting capacity, means we can control that one. Okay. Now examples of conductors, as I told you, silver, gold, copper, steel, salt water, brine solution. Okay. Similarly, brine solution is also a salt water. Okay. Here salt and water will be of equal amount, but seawater is not having that ratio. That's why seawater and brine solution are different. Okay. Similarly, rubber, glass, oil, diamond, dry wood, or you can consider plastic, polymers. Okay, these all are the insulators. They are not letting the current pass through it at the normal temperature. Okay, if we will consider very high temperature, then these insulators are also acting as a conductor. As I told you, that there is a gap between the valence band and the conduction band, and if also able to fill that gap, then what happens? The electrons which is present in band, and it will also act as a conductor. Okay, that you will learn in your capacitor. When you about capacitor in your higher semester and dielectric material, at that time you will learn that this dielectric material are not nothing but the insulators only, and they are using in the capacitor to hold the potential difference or hold the charges. Okay, if the charge is much higher than that of the capacity of that insulator, it will break down at that point and it will let the current pass through it. Okay, and it will not store anymore. Okay, that is what is the insulator. Then comes a semiconductor. In semiconductor, when you have learned uh, and you have learned like resistors, we learn capacitors, IC circuit, integrated circuits, transistor, diode, triode. All these things are your semiconductor, and a semiconductor is a very important thing in case of your electronics. Okay, telecommunication, like starting from your satellite communication or transmission to your television, mobile phones, laptop, anything you consider, this semiconductor is going to play a very vital role. Without this semiconductor, you cannot imagine even all these materials, all these things what we are using right now. Okay, so the very first semiconductor device what we learn, these are the devices. Okay, these are semiconductor devices. These devices are using semiconductor in them. So transistor is that very first what you can say, life changing discovery of semiconductor. Okay, semiconductor was used in transistor, and then everything changed from the transistor. The transistor means, if you are people are aware that older times we were using radios. Okay, so in those radio we were using these transistors. Before radio came, this transistor was only in use. Then from transistor it became radio, from radio it became television, from television it became your telephones. Okay, now we are using the semiconductor in most of the cases. Okay, most of the communication devices what we are having, I'm not only telling this audio or video communication what we are doing with telephones or all the things, even the data transmission. Okay, when I'm telling data transmission means, like we are using telephone to communicate with each other, right? So the telephone what we are using for communication, that is using the signal, right? We are seeing that satellite signal we are receiving and satellite signals we are transmitting, right? That satellite communication is also is using the semiconductor. That's why the semiconductor is a super important material for you people. You being a what you can say, um, electronic engineer, this semiconductor is something very vital in your learning. Okay, now we will see this. To learn this energy band theory, we need to learn, we need to recall what is the Bohr's atomic structure. Okay, we have learned in plus 2 physics, or before that also in school you learn how atomic structure is actually. So we will recall that in atomic structure we are having electron and protons there. Electron, proton, and neutron is there, right? A atom is having the equal number of electrons and protons because it is going to balance the charge of the atom, isn't it? The charge we are going to see. So let us consider some material is having x number of electron, means that particular material is going to have the same x number of protons, that is a positive ion. Along with these two, there are ions are also there, that is called as your neutrons. Okay, these neutrons, a material may be possessing this neutron or may not be possessing this neutron, and this neutron is always going to be associated with the proton only. So at the center we will finding the nucleus, which we can say this nucleus is having proton and neutrons, is a positive charge ion, and around this we are having this orbits. Okay, we are having these orbits, and in these orbits the electrons are going to be present. Okay, so this Bohr's atomic theory is having actually 4 postulates. Okay, how many postulates? 4 postulates. So in that 4 postulates, the first postulate it is saying that electrons are moving around the nucleus. Okay, here you see this one. To make this understand, the first postulate what it is saying, the electrons are going to move around the nucleus, that is the fixed part. This is the fixed part, this is the nucleus part. Okay, the electrons are going to move around this neutron or the nucleus, this nucleus, in a fixed orbit, fixed path. It is following this fixed path. If an electron is present over here, means that electron is no way going to change the path of its rotation. Okay, this is what is the first postulate it is saying, and those paths, fixed path around which the electrons are moving, that is called as your orbit, or we call it as the stationary states, or we call it as the energy labels. Okay, so let us, this is named as your, if n is equal to 1, that is a k cell or k orbit. If the electron is present in this k orbit, the orbit as well as the electron are possessing a fixed amount of force or fixed amount of energy. Okay, that is what is the first postulate it is saying. Because of that we are saying this is a energy label. This is energy label 1, this is energy label 2, this is energy label 3. But that does not mean that between these 1 and 2 there is no more energy level is present. Of course there is more energy levels are present here, n number of energy levels are present, but the electrons are not going to be placed in those energy levels. Okay, energy level means is that means like the particular orbit is possessing some amount of energy that we are calculating in the electron volt unit. Okay, that is called as your energy level, simple terms. Okay, between this 1 and 2 there are many more layers are there which are possessing different amount of energies. Okay, that is called as your energy labels. But electrons are not going to be placed in those different energy labels. They are only going to be placed in the fixed energy labels, like your k cell that is having some amount of energy. In that energy level only they are going to be placed. If they are gaining energy from k cell to the L cell, they are going to jump, that is also having some fixed amount of energy. Okay, that is what is your energy label we are saying over here. So according to the first postulate of Bohr's atomic structure, we can say that electrons are going to move around the nucleus in the fixed path, that is called as your fixed orbit or energy labels. Okay, Here how we will be going to, and also remember here the electrons which are present over here, let us consider here that the electrons are present. This layer is having the lowest amount of energy. Okay, as you are going to increase the number n equal to 1 2 3, then the energy is also going to be increasing. That means if I will say consider m cell, then m cell is having highest energy than that of your k cell. Similarly, L cell is having higher energy than that of your K cell, but M cell is also having higher energy than that of your L cell. Okay, so as you are going away from the nucleus, the energy of the orbit is going to increase. But here another term is there, the attraction force between this electron and the neutron. Okay, the electron which are present at the nearest highest attraction force between this proton is exhibiting, like your sun is there, right? Sun is there and planets are rotating in their fixed path, isn't it? The sun is attracting all the planets towards it, right? So this, due to this attraction forces only they are rotating around the sun, isn't it? Similarly here also this proton or the positive ion which is present in the nucleus is attracting all the electrons towards it. That attraction force of the nucleus on the first layer or first orbit electron is highest than that of the end, what you can say, the external orbits. Okay, so how we will know that whether this is how we are calculating this attraction force of the proton on the electrons? That for attraction force we can say that F is equal to K is a constant value, Q1 Q2 divided by R square. Okay, Q1 is the value of some positive ion. Okay, Q1 is the value of some positive ion. That positive electron, positive value of the charge of positive proton, value of the charge of this negative proton, and this is the R. R is the distance between the proton to the nucleus to the electron present in the cell. So this is your R1, R2, R3. So this, as this R value is going to increase, that like that the value of F is going to reduce. Okay, so this is what is the attraction force between the nucleus and the electron. So what we learn in this postulate, in this postulate we learn that electrons are going to be moving around the nucleus which are having the fixed energy levels. Okay, and the as the cell is moving away from the nucleus, the cell energy are going to increase, but at the same time the attraction force between the proton and the electron are going to be reducing. That means to make a electron leave this orbit, k orbit, energy to that electron so that it can overcome the attraction force between the proton and the electron and can jump to the next level. At the same time, if any electron is present at the outermost cell, then it will be requiring very less energy as compared to the other electrons to leave this energy band and go to the either the void space or to the next energy level. Okay, so because of your, what you can say, because of the attraction force, or we can say that because of the attraction force between the electron and the proton present in the cells. This is what is the first postulate. So first postulate I saying, first postulate is defining us about the orbit. Okay, orbit or energy level. Similarly, the second one is saying, the second postulate is saying the orbit of the electron doesn't change unless and until we are either giving the energy or removing the energy. That means if an electron is present in K cell, this electron is not going to jump. Otherwise, let us consider electron is present in the L cell. This electron is not going to jump to the K cell or not going to jump to the M cell if we are not removing energy or adding energy to that electron. when you are going to add the energy, that means what, either you will give electrical energy or you are going to heat the material. When you heat the material, that absorbing the energy, that means electron is absorbing the energy and it is increasing the energy of itself so that it can jump or it can leave this orbit and jump to the next orbit. Okay, remember this electron can jump to the next orbit only, not the in between energy levels present here. Okay, so this electron is going to jump to the next energy level by receiving the energy from external source. Let us consider this particular atom is radiating some energy. Radiating some energy means it is emitting some light with a particular wavelength. So when it is emitting some light in a particular wavelength, that means this electron is losing the energy, so it will jump to the lower energy level. Okay, that is the second postulate. The third postulate is saying, as I told you, when it is radiating the energy, no, it is having particular wavelength of lambda. Okay, lambda is the wavelength. So this energy, amount of difference of energy in this between these cells, we can define that this amount of difference of energy. Let us consider this particular is having E1 energy, this particular is having E2 energy. Then delta E will be equal to E2 minus E1, because E2 is higher and E1 is less. That's why I can write E2 minus E1, the difference of the energy. Now if this electron wants to jump from this layer to this layer, means it have to release this amount of energy. When it is releasing this delta E amount of energy, it is creating a radiation of this wavelength or light of this wavelength lambda. Then that value will be equal to delta E is equal to hc by lambda, where h is what? H is nothing but your Planck's constant, which you already learned in the, okay. And what is c? C is nothing but the speed of light in vacuum. Speed of light in vacuum. Okay, so this is also constant. This h is constant, this c is constant. This del E value is also constant, because we know that these two are having fixed energy level. That means this lambda value will also be a constant value. That means we can say that if a atom is radiating some x amount, x value of wavelength of light, then that means that its electron are releasing energy from we can say depending on the wavelength. Similarly, we can say from M cell to K cell it is jumping. That means that there is a particular wavelength for that radiation. Okay, that is what it is saying. What it is saying, wavelength of the radiation emitted by an atom is depends on the energy difference. This energy difference or this energy difference or this energy difference also we can say. This energy difference of the initial and final state. Initial and final state means what? Initially where the electron was present and finally where the electron is present. Okay, for example, let us consider one electron is moving from this point to this point. That means this is the initial state, this is the final state. From initial state to final state, it is going to change its position. That is what is your that is what is going to be telling that third postulate. And fourth postulate, it is saying that angular momentum of the electron is quantized, means fixed. What do you mean by angular momentum here? Angular momentum means what? Momentum means, you can say in simply, if I put it, I can is a name and I can say it is a inertia. Okay, we can say it is a inertia. So let us consider this is the center. This is the center of a particular thread which is having a stone over here, and the stone is we are rotating that one. Okay, at this particular position, this is the direction of movement. But because the stone is attached to the center with a thread, that's why it is attracted towards. It is not going to be leaving this particular orbit. So for each time, the direction of the movement is different, and the amount of energy is always going to be attracted towards this. There is a particular energy which is attracting this one towards the center, right? Due to this, there is a momentum is created in the material, and if it is, as it is moving in an angular direction or angular path or a circular path, that's why we call it as a angular momentum. And for electron which is present at a particular, let us consider electron is present in K cell, then its amount of angular momentum is fixed because this distance is fixed. Okay, so to calculate this angular momentum, we are having, let us consider this is the electron which is moving, this is the center of the nucleus, and this is the electron, this is nucleus, this is the electron, right? This is r distance. This electron is having a particular mass of m with the velocity v, it is moving. Then angular momentum mbr is equal to h by 2 pi, which is supposed to be multiplied with a n. Okay, h is a constant, Planck's constant. This 2 pi is also constant, that means mbr is constant value, right? So if you are going to, you are supposed to multiply this n with 1 2 3 4 like that. Why? Because we know that this angular momentum can never be a intermediate value. Intermediate value means it will not fall in between this energy level, because these energy cells are fixed. It is 1, it is 2, it is 3. That's why you have to multiply 1 2 3, and these are the constant. So for every cell, the amount of angular momentum of the electron is fixed, which is energy value, or we are saying this is the energy packet, and that is fixed for each and every cell electron for the cell. Okay, this is what is your 4 postulates given by the Bohr's atomic structure. Okay, is there any doubt in this one, Bohr's atomic structure? I am waiting for the message from you people. If you are having any doubt, you can ask me now in the chat box now, or else you can ask me later also. Whenever you are following this, referring this video also, if you have doubt, you can put me message in WhatsApp. Okay, so this is what is the Bohr's atomic structure. So remember this Bohr's atomic structure for tomorrow's class, because in tomorrow's class we are going to learn the energy band, as well as we are going to learn the different types of semiconductor what we are using it. Okay, so today I am ending the class over here. I think you already got the link for calculus class. People can join the class, and we will be meeting tomorrow for the same particular topic. If you have any doubt, you are free to put the message even after the class. Okay. Lavanya, do you have any doubt, Lavanya? Let me unmute you. Now you can unmute yourself. Ask your doubt, what you are having. If you are
Ma'am,
having
once
any
tell
doubt.
me the second postulate, ma'am.
Second postulate. Second postulate is saying that orbit of the electron doesn't change. Orbit of
Okay,
the
ma'am.
electron doesn't change unless energy is added or removed.
Okay, ma'am.
Unless energy is added or removed. Okay. Are you noting it down?
Okay, ma'am. Yes, ma'am.
Okay. Okay. That is what is the second postulate. Clear? If you people are having any other doubt, you can just put it in the chat box. I will see later and I will clear your doubt. Okay.